Hi GOH, this is Unit 5, Lesson 10, and today we're talking about perpendicular bisectors. So the first thing that we're doing is we're constructing the perpendicular bisector. So take out your compass. I've already done this one for us, but I want you guys to do it on your paper. So remember, the perpendicular bisector is my favorite construction. I put my compass on point A. Make sure that you open it more than halfway. And I draw half a circle. Then you move it over to point B with the same setting. I'm going to draw half a circle, and where those two half circles meet on the top and at the bottom, that's what I'm using to connect and draw that perpendicular bisector. So that line that you just drew with your straight edge right here, I'll highlight it for us. That line is perpendicular, means it forms a right angle, and it bisects. That means it cuts it in half. So we're going to write the equation of the perpendicular bisector today. So I just wanted to remind you of what a perpendicular bisector actually was. Now this is sort of putting together a lot of concepts. It's a bisector, so I need to find the midpoint. It's perpendicular, so you need to find the slope, but then you're going to do the perpendicular slope. So there's a couple steps, and I walk us through those steps in example 2 that I have right here. Now technically for example 2, I don't need to do all the steps because I'm just talking about vertical and horizontal lines, but we will just go through those steps anyway. So here's what I have. Write the equation of a line that's perpendicular bisector of the line segment having endpoints of 3, -1. So I'm going to plot 1, 2, 3, -1 is right there. And 3, 5. 1, 2, 3, 4, 5. Okay, so there's 3, 5. So I want the line, and let me connect them. I want to write the equation of the line that's perpendicular to this and that cuts it in half. All right, so the equation actually is going to be right smack in the middle, and it will be at this line that I'm drawing right here in purple. All right, and the equation of that line is y equals 2. Now that's the answer, but how do I do this if it's not a vertical and a horizontal line that I can just see? Oh, it's right smack in the middle there, that's perpendicular. Step 1 is you find the midpoint of that line. So I add the x's and I divide by 2, and I add the y's and I divide by 2. So the midpoint is going to be 3, because 3 plus 3 is 6, divided by 2 is 3, and -1 plus 5 is 4. 4 divided by 3 is 2. So the midpoint, the point right in the middle there, is 3, 2. And then it's got to be perpendicular to that. So the next step is to find the slope of the original line. So my original line, which had the points 3, -1, and 3, 5, I'm going to find the slope. So it's going to be y minus -1, 5 minus -1, y minus y, over x minus x. Now the reason that this is different is because this is a vertical line. It actually has no slope. So a perpendicular line would be a horizontal line. All right, but normally you're going to find the slope and then you're going to do the negative reciprocal of it. This is unusual because it's a vertical and a horizontal line. And we already know the answer. The answer is y equals 2. All right, so let's try a real problem that we're going to have to do all those steps for. Write an equation of a line that's the perpendicular bisector of the line segment having the endpoints of -2, 7, and that should be an 8, -3. Perfect. So step 1, find the midpoint. To write an equation of a line, you need a point and you need a slope. Here's my equation of a line. The slope is going to be the perpendicular slope, and the point is going to be the midpoint because it's a bisector. So the midpoint, I add the x's, divide by 2, add the y's, divide by 2. So -2 plus 8 is 6. 6 divided by 2 is 3. 7 plus -1 is 6. 6 divided by 2 is 3. All right, so that's my point, 3, 3. Now I have to find the slope. So the slope of my original line. So -1 minus 7 over 8 minus -2. -8 over 10. Now let's reduce that. Is -4 over 5. Now that's not the slope I want. I want a perpendicular slope because remember this is a perpendicular bisector. So the perpendicular slope is I flip it and I change the sign. So you are going to take your midpoint and you are going to take your perpendicular slope and you are going to write your equation. So y minus 3 equals my slope 5/4 x minus 3. And that's it. That's my answer. So it's writing an equation of a perpendicular bisector. So you have to know how to find the midpoint. You have to know how to find the slope. And then you need the perpendicular slope. You need to flip that. And then you're going to take that midpoint and that slope and you're going to plug it into your point slope formula. Now, they gave you the graph if you wanted to use the graph, but it's certainly not necessary to do that. All right, exercise 5. In the graph below, AB is drawn with endpoints of A, which is -1, -3, and B, which is 3, 7. We want to find the coordinates of the midpoint. Basically, what we're doing here is they're doing another problem, and they're just walking us through it step by step to make sure that you understand that. So I'm going to find the coordinates of the midpoint. I'm going to add the x's, -1 plus 3, divide by 2. Add the y's, -3 plus 7 divided by 2. -1 plus 3 is 2, and 2 divided by 2 is 1. -3 plus 7 is 4, and 4 divided by 2 is 2. So that's my midpoint. The next is to find the slope. So my slope of AB, I subtract the x's, that goes on the top, 7 minus -3. I subtract the y's, that goes on the bottom, 3 minus -1. 7 minus -3 is 10. 3 minus -1 is 4. Now you can reduce that. They're both even numbers, so I'm going to divide by 2, and I get 5/2. Now I want to first draw the perpendicular bisector, and then I'll write its equation. So remember, if it's perpendicular, I need the perpendicular slope. So I have to take that slope of 5/2, and I'm going to flip it, and I'm going to change the sign. So now I am going to start at my midpoint which is 1, 2, which is right here. That's my midpoint. And then I'm going to use that slope of -2/5. So I'm going to go down to 1, 2, 3, 4, 5. And I'm going to go up to 1, 2, 3, 4, 5. So this red line that I'm drawing is perpendicular and it bisects. It cuts it in half. I'm going to confirm the fact that it's a bisector down below. Now, how do I write the equation? I use the midpoint, and I use that perpendicular slope to write the equation. So y minus 2 equals the slope, which is -2/5, x minus 1. And that's my equation right there. Now, part D wants us to find the coordinates, state one point other than M that the perpendicular bisector passes through. So I'm going to call that point D, and I'm going to use the point, all the way over here. I'm going to call that D. So D has the coordinates of 6, 0. All right. And I want to find the length of AD. So let's say that I was connecting, I'll do that in a different color, green. If I was connecting A to D, I want to find the length of AD, and I want to find the length of BD. Okay, so the length of AD, so A is -1, -3, and D is 6, 0. So I find the length, I use my distance formula. x2 minus x1 squared plus y2 minus y1 squared. 6 minus negative 1 is 7 squared. 0 minus negative 3 is 3 squared. 7 squared is 49, and 3 squared is 9, which is radical 58. The length of BD. Now B was 3, 7, and again D was the point that I picked, 6, 0. They wanted me to pick any point on that line, and I'm going to do the length of BD. Again, find the length. I subtract the x's, 6 minus 3 squared, and then I subtract the y's, 0 minus 7 squared. So that's 3 squared plus negative 7 squared. 3 squared is 9. Negative 7 squared, I'm squaring that, so it's 49. And 9 plus 49 is 58. Now what's true is that point D is equidistant from the endpoints of that line segment. And that's something that we knew before. Any point that's on the perpendicular bisector is equidistant from the endpoints of that line segment. So point D is equidistant from the endpoints of the line segment. And somehow this next lesson sort of got into this lesson. All right, but that's it. So we're going to practice writing equations of perpendicular bisectors tomorrow. It's really pulling into everything that we